Cool. Okay, so good morning or afternoon or evening, everybody. Thanks for joining us. My name is Gaurav Manchanda with Formlabs Healthcare. I'm pleased to be joined by Dr. Adil Akhtar and James Austin from Psionic. As you'll come to see and hear, Psionic is a fast-growing startup using 3D printing in a variety of ways for a range of applications, including manufacturing aids and in-use parts and prototyping as well. And just wanted to spend about the next 45 minutes to an hour sharing their story, given the innovative nature of the work and the clinical impact that it has on their target audience. So Adil and James, thank you for joining me, first of all.
Thanks for having us.
Good to be here.
Where are you joining from this morning, or my morning?
So we're joining you from San Diego in our new offices. We just moved in here about a month ago.
Oh, very nice.
Bright and early on the West Coast time now.
Well, thank you for the bright and early start, and a little jealous dialing in from a cold autumn in New England. But but all that said, for a brief intro on Formlabs, naturally, I think for those listening in, if you don't know, we are a manufacturer of 3D printers and materials and associated software to enable folks like Psionic and others in the medical and healthcare space to print a variety of medical devices, including prosthetic devices. And Formlabs is really just getting started, I would say, in the orthotics and prosthetics, or O&P space. And this is one of our real hero examples, I would say, for how folks are using SLA in particular to create end-use devices. So with that said, I think pictures say 1,000 words and videos say even more. So we'll start with a video to give everyone an idea of what Adil and James are doing.
Touching my daughter's hand with this prosthetic hand because of the sensory feedback. I was a U.S. Army infantryman. I deployed to Iraq with the Illinois National Guard, the 33rd Infantry Brigade. On October 15, 2005, we hit a roadside bomb where it detonated under our vehicle. It blew the engine out of the truck. I broke my jaw, 7 spots. I was mild traumatic brain injury, and I lost my arm below the elbow. When I got back from Iraq, I got back to normal life. I got my undergrad, I had 2 children as a stay-at-home dad. Fortunately, I got linked up with this promising PhD student who had this great idea for a prosthetic named Adil Akhtar and his company called Psionic.
This is something that I've wanted to do my entire life, ever since I was 7 years old. My parents are from Pakistan. I was visiting, and that's the first time I met someone with a limb difference. She was my age, missing her right leg and using a tree branch as a crutch, and that's what inspired me to want to go into this field. At Psionic, we develop advanced bionic limbs that are affordable and accessible to everyone. We would not have been able to create this hand unless we had the manufacturing in-house with the Formlabs printers. And it's really been a game changer for not just us as a business, but also for the industry as a whole. Our patients, what they're looking to do is just do their normal activities of daily living, right? So just feeding themselves, tying their shoelaces, going to the gym and working out. A lot of the devices that are out there, you couldn't even do some of those simple tasks.
It's sort of the small things that you wouldn't think that you would miss. It's those things that you take for granted a lot of times. The ability to know that you have something in your right hand. I can actually drive with this on the car and just steer. I have sensory feedback that tells me how hard I'm gripping, if I even have something, and if I crush it or not.
There's no way we could have competed with other prosthetics companies if we had to abide by purely traditional manufacturing. 3D printing, especially the Formlabs 3D printers, has come in absolutely critical for that development process for a startup our size. While some of the 3D printing we do with SLA printing is for prototypes, a lot of it is in fact for end-use product. This is especially true of the TUF 1500 resin, which is still superior to any other 3D printed item we could make in terms of strength, resolution, physical properties, thermal resistance, impact resistance. The TUF 1500 is honestly the best thing we found, and we continue to use it in all our commercial devices.
Some of the biggest challenges we've faced is how do we make this hand still low cost for us to manufacture, but more durable than anything else that's out there. Before our hand came along, what we call a multi-articulated hand where all the fingers can move individually, it was only covered by about 10% of insurers in the US. By getting it covered under Medicare, we've expanded that access to 75% of patients who can now afford the most advanced bionic hand in the world.
We use clear resin to mold at least one silicone part, primarily the silicone fingers and silicone thumb. The surface finish needs to be as smooth as possible, and we found that we get the smoothest surface finish from running it at the 25 micron resolution size. With FDM printed molds, molded items would end up with these odd striated, striped textures on top. Once we switched over to using clear resin, we were able to obtain a much smoother surface finish because of the much higher resolution.
The fact that we can actually manufacture everything in-house has been critical to our operation. We've innovated a lot of the manufacturing techniques for making those processes.
If we didn't have these printers in-house, if we had to go to third-party or export them, it would slow our development and iteration process dramatically. The fact that we're able to design a part in CAD, take it to our printer, print it within a day, and have it come off means our iterations can move so quickly and our testing can be rapidly accelerated. I'm not sure we would have been able to function if we had to wait a week for parts to come back. We wouldn't have been able to develop as fast as we could have, and we wouldn't have been able to get to where we are today. So amazing to see people get back part of what they've lost. And we've had prosthetic patients actually tell us like it feels like a part of them has come back to life. They're able to do things that they were never able to do after their amputation.
They haven't stopped innovating in the technology and upgrading what needs to be done. They're trying to figure out how can we improve what we have.
Sergeant Anderson has tried basically every prototype that we've ever made of the ability hand over the last 7 years, and he has been critical to the design of this because if it can survive him, then we know it can survive anyone.
Oh, so thank you both again. I know that we just filmed that video about 6 weeks ago or so. That was in your previous offices, is that right?
Yes, that's right.
Seems like a lifetime ago.
Yeah, right. Yeah, that was back in Champaign, Illinois, where we were for the last 7 years or so, and then yeah, when we just moved over to San Diego like a month ago.
Got it. Okay. Well, before we get too far, maybe we saw your titles in the video, but maybe you could just share some brief individual introductions about yourself, and you mentioned the background in Illinois as well, but just your degrees and your backgrounds would be helpful.
Yeah, absolutely. So I'm Dr. Adil Akhtar. I'm the CEO and founder of Psionic, and this is something, as I had mentioned in the video, what I wanted to do my whole life was to develop bionic limbs ever since I was 7. And I visited Pakistan. I met someone with a limb difference for the first time there, living in poverty and missing her right leg. And so I went to Loyola University Chicago, got a bachelor's degree in biology. Original plan was to become a medical doctor, and I was pre-med, and I took my first computer science class my sophomore year of undergrad, and I loved it, and I wanted to figure out a way how I could combine the two. And that was when I came across some of the bionic limbs that were technologies that were being developed at the Rehabilitation Institute of Chicago, now known as the Shirley Ryan Ability Lab. And they had some breakthroughs in mind-controlled bionic limbs, and it was the perfect combination of engineering and medicine, and it was exactly what I wanted to get into. So I got a master's in computer science from Loyola after a bachelor's in biology. I taught there for a couple of years, came down to the University of Illinois at Urbana-Champaign, and then I joined the MD PhD program there. I got another master's in electrical and computer engineering, a PhD in neuroscience. And then after the first year of medical school, I left to run the company full time because this was a lot more fun. But it was while I was doing my PhD that we got the chance to go down to Ecuador and work with a nonprofit called the Range of Motion Project. And there we met a man who had lost his left hand 35 years prior due to machine gun fire from a helicopter. He was in the Ecuadorian army, Juan Suquillo. And at the time that our prosthetic hand was 3 times the size of an average adult human hand, had wires going everywhere, plugged into breadboards, plugged into the wall. But despite that, Juan was able to make a pinch with his left hand for the first time in 35 years. And he literally said in front of international news stations that he felt as though a part of him had come back. And that's when we realized that if we want everyone to feel the exact same way that Juan did, we had to commercialize this technology. So that's when Psionic was born. And so we ended up entering our school's business plan competition. We won that. We won the Illinois Innovation Prize, several grants from the National Science Foundation, a seed round. And then as of September of last year, the Ability Hand, which I'm holding right over here, is available nationwide and covered by Medicare.
Quite a number of achievements there. And I don't want to overlook all of the sort of unique value proposition that you offer. So we can get to that as we continue here, but really congratulations on where you brought the company and the device itself. James, would you like to share your background as well?
Tough act to follow. I only got 2 degrees, so a little less to keep track of. But I'm James Austin. I'm the lead mechanical engineer here at Psionic. I did my undergrad in mechanical engineering with a minor in biomedical up in McGill University in Canada. I always knew I was really interested in robotics and in biomedical devices in general, but I wasn't sure where I wanted to go with it. I toyed around working in satellite design for a few years until I finally figured out that prosthetics was the perfect combination for me of robotics, biomedical integration, and being able to help people on a personal level. So I enrolled in a master's thesis in mechanical engineering at the University of Alberta in Edmonton, which has one of the premier prosthetics labs in North America, the Blink Lab. I did my thesis there on prosthetic control. Loved it, loved the work I was doing. Was trying to find some work after the fact. Prosthetics isn't a gigantic industry, so it was a little tough looking around. And as I was looking around the continent, I just so happened to stumble across this teeny tiny little startup in Champaign, Illinois, which I didn't even know where that was. I thought it was part of Chicago. But I emailed them. I went to check it out. Visited the lab in like one little room at that time, I think, in an incubator in Champaign. And I just fell in love with the vibe, like the scene they had going on, the passion, the innovation, and Adil's energy was just so great and so contagious. I knew that's what I wanted to work for. So I took the job as lead mechanical engineer. It was 4 years ago now, and been chugging along strong ever since.
Oh, and that's great to hear. And maybe you can give me an idea, or would you mind sharing how, in terms of the company size or how many employees there are, things of that nature?
Yeah, so we've got around 10 employees currently. So we're pretty small, but we're pretty powerful. I mean, these hands have been actually all around the world now. We've got some in Europe as well as all across North America. Yeah.
Yeah. I mean, just to think about having a compliant medical device that's been commercialized and adopted by Medicare as a 10-person company is pretty very commendable. So, and I think that brings us to why we're getting together in terms of how you got here on the technology development side. And I know there's a range of other, using 3D printing is naturally for the creation of the hardware, but I know there's a range of other sort of smart features that we'll talk about as well, probably leveraging your computer science background, Adil. So with that sort of table being set now, maybe to get into the 5,000 foot view, maybe James, I can pass over to you in terms of, or Adil, if you want to start as well, but what you were doing, how are you doing product development before leveraging 3D printing, if that period existed, and how you first leveraged 3D printing and the sort of evolution would be great to hear.
You can speak probably pretty well to that to start with because you've worked the longest.
So when we first started, we started by 3D printing open source designs that were available online. And the very first prototype of the arm that we had built was based off a humanoid robot called InMove that you could build for about $1,000, and we modified it so it was just the arm. And typically the way that these hands are controlled is that if you're missing your arm, let's say below your elbow, then you would use muscle sensors to control it. And so we were taking these 3D printed robot hand designs online, and then using our muscle sensors to control them and starting to give sensory feedback to users by playing around with different silicones and different molding techniques to put sensors in the fingers. And these were all FDM printed, right? The standard, I mean, this was back in 2013 when it was first starting to become like commercially popular FDM 3D printing. And so, we're talking about like PLA, ABS, those materials used to develop these hands. But it was after we had come back from that Ecuador trip, we had met Sergeant Anderson, who you saw in the video, and we talked with hundreds of patients and clinicians. The number one thing that they all complained about wasn't necessarily that it was just that these hands were really expensive, but also that they would break very easily. And it wasn't because they were doing anything crazy with it. They would accidentally hit their hand against the side of a table. And because they were made out of these rigid components, they would just snap at the joints. And our own fingers, they're compliant, right? They have flexibility to it. So when you hit it, it bends out of the way and comes back. And that's what gives our own natural hand that resilience to these impacts. And so we were tasked with the challenge then of how can we still leverage the low-cost manufacturing of 3D printing, but make these hands more robust than anything that's out there, right? And that's when we started looking into the soft robotics literature in particular, right? And with soft robotics, instead of making the components of the device or the robot or the hand in our case out of rigid materials, you would use soft materials like silicone, for example. And instead of actually 3D printing the finger itself, we would 3D print a mold and then use a low-cost for example. And then we would use a low-cost silicone to inject into that mold in particular. And so we started continuing down this route. And then over the last 7 years, I think we've gone through 9 full prototypes where we've started from scratch and redeveloped the hand from basically first principles. Again, based on what we learned from the previous iteration. And so James can go in a little bit more in depth on what particular 3D printing techniques we used and the materials in order to make this hand so robust.
Mm-hmm.
Sure.
Please, yeah, go ahead, James.
That's a great overview. I actually came in, funny enough, pretty much exactly the same time as our first Formlabs printer at Psionic. I think it might have even been my first job that I ever had to do was set it up. So I came in with Formlabs from the start there, and Psionic had been using different types of 3D printing since its inception, since the very beginning. But having Formlabs added a whole new range of options for us. We had been, for example, FDM printing the molds, but they would turn out with striations and not the nicest surface finish. Having the clear resin available all of a sudden meant that we could make these beautiful, smooth molds for beautiful, smooth fingers that would come out. And it just opened up our options for 3D printing considerably. And we like to leverage not just one technology, but all the technology we have available for different optimizations. So we do still use FDM for some places where it makes sense. For example, our finger bones are FDM printed specifically because we can do them with a dual extrusion nozzle that makes them out of both a flexible material on the inside and a hard material on the outside. So that allows them to be compliant, as Adil mentioned, but also have hard rigid edges so they're not susceptible to damage. We use clear to make the fingers because of the high surface finish. And then a lot of the internal components of the hand, as I mentioned in the video, they use Tough 1500. When that came out, very fortunately, the predecessor for Tough 1500 Durable came out that summer that I joined, Durable. Just as we were developing, I think, Mach 7.
Yeah, Mark 7.
It would have been Mark 7, which I was tasked with coming on board with redesigning in a new CAD program from scratch, basically, and redesigning it to be smaller, lighter, but also tougher and also water resistant. So there was a lot I had to put together here. And I wasn't sure how I was going to do it. But luckily, Durable came out at just the right time. So these precise little SLA 3D printed drivetrains that I designed suddenly had a material that they could be made out of that was impact resistant and strong enough to withstand hands forces as well. Mm-hmm. So we started using Durable for a lot of the internal components. And then once Tough 1500 came out, we upgraded to that. And we may even upgrade to another material in the future when it comes out. We're always looking at the new materials and new 3D printing technologies to upgrade whatever aspects of the hand we can.
Perfect. So James, just to recap, I think I heard a bit of a few different buckets of applications.
Yeah, there's a lot we use. So it's hard to cover it all in order.
So and one that you might not have mentioned was jigs and fixtures as well, right? Yes. In your manufacturing line. So do you want to speak about that as well?
Absolutely. So in addition to a lot of the components inside the hand, both prototyping and finalized products, in the manufacturing of the hand, we also leverage 3D printing in lots of different ways. Because we do so many things in-house, it means that we need to basically create our own tooling all the time. And a lot of the time, the easiest way to do that is to just design it and 3D print it. So very simple example, we have gears that need to be assembled together. And instead of having to pin them by hand and be inaccurate, we just designed a little jig that holds the gears for us and makes them perfect every time. And it's just that sort of thing where it's like, we have a task that's a little unusual, it's specific to our needs, but we can just design something in CAD, print it out, and there we go. We've got a tool that works for us now. That's really another part of what's allowed us to do so much in-house manufacturing, is the ability to make our own tooling as well.
And could you speak to where the manufacturing is taking place? So you mentioned producing unused parts and the manufacturing line, also using 3D printing, but where is this taking place? Which country, et cetera, just at whatever you can share.
So we actually do all of our manufacturing in-house. So all of the carbon fiber work, all the silicone molding, all of the fabric, all the assembly of the hand in our offices here now in San Diego, previously in Champaign. And so this is a made in USA product that we're developing, and it wouldn't have been possible without leveraging 3D printing and Formlabs printers as well.
Yeah. So what I'm thinking about, you're using 3D printing in a variety of novel ways, right, across the entire R&D and end-use part and manufacturing line. The hand itself, maybe to get into the details of the performance of the hand and what it's capable of, because I think we're almost implicitly comparing 3D printing to traditional manufacturing. So I'll ask you about that in just a moment. But all of the uses of 3D printing. What does that actually enable? What is that enabling in simple terms in the performance of the hand itself? Maybe from the perspective of a patient or from your own view.
Yeah, and so for the patients, it's all about what they're able to accomplish in their daily lives, right? And we wanted to make sure that this hand would be able to withstand basically most everything that they would do, like simple activities of daily living. And in order to demonstrate that, we wanted to do some more extreme challenges with the hand, right? So for example, I arm wrestled against the para triathlete national champion of 2018 and 2019, and I ended up losing. So I need to start working out a little bit more. I'll get my revenge, but he's also able to break boards with this hand, so I don't know if I want to challenge him again. Right. But the thing is, if we can build a hand that can break through 3 boards on fire, which is one of the things that we actually did with Sergeant Anderson a couple months ago.
Copy that video coming out.
Yes. Then it should be able to survive him doing daily tasks, right? If he accidentally bangs the hand against the like a wall or like a table, or if he's even things like working out or opening a refrigerator door or holding his food or using a fork and a knife in both hands, right? Those are the types of things that we've been able to enable because of the material choices that we've used here, right? So the carbon fiber keeps the hand light and strong, but underneath it is a 3D printed palm that we can form much better around our motors, around the internal components of the hand itself. And I think one of when we first got that durable resin and you printed out some of the internal components of the hand, the first thing that I would do is I would throw it against the wall as hard as I could, just to make sure that this thing could actually survive that kind of impact. And we did the same thing with the Tough 1500 once we started using
very standard test.
Yes, very standard test. If I throw it against the wall as hard as I can, will it survive? And we're comparing this against other manufacturing methods and other hands that are using traditional manufacturing methods like injection molded plastics and custom machined steel. And as I was mentioning earlier, because those joints are rigid, when they impact an object, that's when they end up breaking, is because they don't have that flexibility, they don't have that compliance. So by using materials that are compliant, and by using molding techniques that can leverage 3D printing in order to enable those compliant structures to come into existence, we're able to then build them so that you can take this and I can smash this and it survives that impact.
Yeah, and I guess just to sort of maybe paint a picture for how far at the innovative end of the spectrum your device is. You mentioned the tree branch, right? And I know there are different situations and resource limited settings. And you mentioned Pakistan, right? And we're using the tree branch. And in the video even itself, there was an image of the essentially a hook, right, that's being used by some folks, unfortunately. And having your dynamic, responsive hand in comparison is it feels like a night and day difference. And I imagine that's what you're hearing from your patients and your customers as well.
Yeah, absolutely, absolutely. And we have an eye for the future in a lot of this technology too, and we're kind of where it's heading. So we start with the tree branch and the hook, and then these multi-articulated devices that allow our users to do different grips. But eventually, we plan on integrating these technologies directly with your body. So we're talking about nerve implants, brain implants, so you can actually control it as naturally as you would a natural hand.
Mm-hmm.
I will say on the topic of this innovation, another advantage of 3D printing that maybe isn't as evident just in the final result, some of these materials we could probably do with some traditional manufacturing, like the plastic, maybe we could choose something to be injection molded, maybe some parts could be made from metal. But the overhead cost to be doing that, to be getting the injection molds mass made, to be getting the metal shaped in machine shops, which we didn't have access to when we started, that would just be massively expensive. And the number of iterations we go through, like we prototype at such a rapid rate. We are iterating constantly, just day after day after day. That's how we reach such advanced technologies that Idil's been talking about. And that's how we have such an eye for the future. Mm-hmm. But we couldn't do that if we had such overhead that was required to make the things we make with traditional manufacturing, like injection molding or machining. It's only because we have such rapid prototyping ability with 3D printing that we're able to advance as much as we do.
Mm-hmm. And I know you sent over a few slides that I can pull up now, but just to get into sort of what this, in a visual sense, what this enables for your patients. And now that we sort of understand the traditional landscape and the smarts of your device, I just wanted to pull up a couple of slides here, and you both can call out which ones you'd like me to stop on. But let me pull this up just a moment.
Yeah, I mean, we can go through a bunch of these.
Every slide's great.
Yeah. So yeah, if you want to go ahead and play this one, for example.
Yeah. Okay. Just a moment.
And so this is one of our users who is an 80-year-old triple amputee who lost his limbs due to sepsis. And this was him grasping a hollow eggshell without cracking it while blindfolded on his first try. And the reason for that was because our hand is the only one on the market to give users touch feedback. So we have touch sensors in the fingertip, the finger pads, and on the sides of the ends of the fingers. And with that, he's able to actually feel a vibration when he touches the eggshell. And the hand is actually able to slow down automatically when it comes into contact with an object to keep you from crushing it. And to be able to have that delicate touch, I mean, Sergeant Anderson, he can hold his daughter's hand and feel it, right, without crushing it. And that is something that, that's why we do what we do, is to enable those moments for our patients.
Are you ready?
And then, this one was 3 minutes after Dan St. Pierre was fitted with the hand, and he was able to catch a bottle because of the speed with which he is able to control the device. And then the next video shows, me arm wrestling him, and
loses.
I have to relive this every single time I see this video.
Well, we won't have any spoilers here. You have to tune in, see what happens there.
And then with this one, if you remember that bottle flipping, it was you can imagine it's a lot harder to do with a bionic hand. And one of our patients, Kate Kettleholm, she came to our labs and she was able to just nail these crazy shots like all over the offices in the building, and that was just a lot of fun for us to do. And by having them able to do these types of grand challenges, it also just gives them confidence in what they can do with a bionic limb that they never thought was possible before. And honestly, we never thought was possible before. So we are always pushing the boundaries of possible with these limbs. So for example, here's the flaming board breaking video with Sergeant Anderson. And he didn't even know that he could break through 3 boards on fire, and he feels a lot more confident in doing these more extreme tasks and of daily living that might require a more durable hand.
Just looking at this one, what has the feedback been about any pain on that joint where it does connect to the I guess the biological the stub, or I don't know the proper term for it.
Yeah, we haven't if the socket is properly made, then it's not as much of an issue. And so the Sergeant Anderson and Dan St. Pierre, the ones who have been doing the most board breaking, they got their sockets made by a prosthetist out in Chicago named Dave Rotter, and he is one of the world's best prosthetists. Like his clientele are all like Paralympic gold medalists, and Tammy Duckworth will fly in from Washington, D.C.
If you're watching this, Dave, we love you.
And so that being said, sockets do have their issues. And there are a lot of companies that are working on 3D printing sockets and kind of and working on in those ways to seeing if they can make them more comfortable for users as well. One of the things that we're looking towards in the future, though, is something called osseointegration, where instead of using a socket to attach the hand to your residual limb, you would actually connect it directly to your bones. And that is much more natural. That's how a natural hand is connected to your body, as well as through your bone structure. And part of the reason why we moved to San Diego is to work with the military hospital and UCSD and a lot of the other players in this space, in this area, to kind of bring this bionic technology to the next level. Our goal is to turn San Diego into the bionics capital of the world through these, neurally integrated, bone integrated prosthetics that are much more akin to a natural hand. We've got plans to make an ability leg that you can do a triathlon in, and it's the triathlon capital of the world here. So hopefully in the next 5 years, we'll have our patients running, biking, and swimming in an ability leg.
Incredible. I imagine you're evaluating the full range of print engines as a result. So do you want to speak about, you mentioned FDM a little bit earlier, James. Do you want to speak about any evaluations of other SLA and other, if you're considering SLS or?
Certainly, yeah, sure. Like I said, we're always looking at new materials and seeing what's coming out. And there's been a lot of innovation in the SLA and now SLS field specifically. We're looking at some of the sintering and carbon fiber. I think one that was of particular interest to us was the nylon 11 CF. Yes, that's the one that just caught our eye recently, since it has almost all the equal properties or better properties to Tough 1500, but better heat deflection temperature. Which is yet another issue that you can run into with hands that you don't really run into with biological limbs, is that they're working so hard with all our motors put to max efficiency that they can generate a lot of heat. So we have to come up with a lot of clever strategies to distribute that and manage it as effectively as possible. And having new material options like this can give us new ways. Of course, the conductivity of carbon fiber doesn't hurt either. So that's, I think, the nearest thing we're looking at. We're pretty happy with a lot of our FDM stuff at the moment because it's mostly used as sort of a skeleton, and then the really strong functional stuff goes on top and around it. But we periodically go back and revisit to see if there's new printers with better resolution, if there's improved materials, this sort of thing, and upgrade accordingly.
And one of the reasons why we were looking at the Fuse in particular, the Fuse 1 Plus that we, the nylon 11 CF was because the build chamber was just so much larger. We'd be able to scale our manufacturing from, just with the build plate that we're using with Form 3 going to the build chamber of the Fuse 1 Plus, that we'd be able to make hundreds of hands worth of components as opposed to just maybe 10 at a time, for example.
Scaling is a lot of interest to us, especially right now. Now that we're in San Diego and have our own huge office that we need to fill up, we have pretty much more hand orders than we can fulfill at the moment. So we're really working on scaling up our manufacturing. The bottleneck's not just in 3D printing, it's everywhere. But we're looking at ways to improve and enlarge and scale up all our operations. And 3D printing means considering bigger printers, newer printers, that sort of thing.
Yeah, and something interesting too is that recently we've been finding that a lot of robotics companies have been approaching us as well, in addition to just patients who are missing limbs and clinicians with those patients. And those robotics companies, they're building robots to do human tasks. And we've actually optimized our hands for humans to do human tasks. So it makes logical sense that they use something that's already out there. And so, for example, Facebook bought a couple of hands and they're putting them on industrial robot arms. And then NASA actually recently bought one too. And the idea here is that, we'd be able to remotely teleoperate these humanoid robots, and then they'd be able to do similar to what humans would do, whether it's somewhere across the entire world or in space even, right? And because of that, we need to start scaling our manufacturing. And so by looking at things like the Fuse and newer technologies that are coming out as well, we can start answering those questions of how can we go from like I said, building 10 hands a week to hundreds of hands a week to even more in the future.
So there's, I can't wait to follow your progress and your product roadmap as it evolves. I have a personal connection I have a family member who has CP and mobility challenges as a result, and a deal similar to your story from Pakistan. I'm from India. India before the internet was a different place in terms of poverty levels and whatnot, and also worked in Liberia for a number of years. Lots of former child soldiers missing limbs and using all sorts of inadequate devices. So really proud to be working for Formlabs and enabling the sort of work that you all are doing. In terms of you mentioned a bit of the I guess the manufacturing scalability plans and the product roadmap with a prosthetic leg as well. Adil, you mentioned in passing almost some of the features that you're developing. Do you want to speak a little bit more about what's on the roadmap there?
Yeah, absolutely. And so I've got the ability hand right over here, right? And so all 5 fingers flex and extend, and some rotates as well. So, you can do your spirit fingers right over here, right? And the way that this typically works right now, so let's say that if you lost your hand below your elbow, you have muscle sensors that are placed on your residual limb, and you could use that to switch between different grips, right? So these are pre-programmed grips that are on here, right? So for example, if I'm at a rock concert, I can rock on, right? If I want to do a precision pinch, I can do that right over here. And then the tried and true here is the power grasp, right? You can use this for and a key grasp right over here, right? So those are
very, very. What's the layman answer for how are you actually controlling the hand right now?
So I'm controlling it with these 2 buttons right here. And those 2 buttons are basically emulating your muscle signals, right? So for example, if I were to flex my muscles very lightly, I can control the speed of the hand to go very slowly, right? Or if I flex them much harder, then I can make it go much faster. And those 2 grips that you saw right there, the power grip and the key grip right over here, they count for about 80% of all the grasps that are typically done on a daily basis by users. And then the rest are the precision pinch and different various gestures that they might want to make, right? Now that being said, that isn't the typical way that you control a natural limb, right? And because of that, what we're starting to look into is these neural technologies, and this is the goal was from the beginning was to work with these biointegrated technologies that give you things like individual finger control, right? And so I was mentioning a little bit about that earlier. And so I'm just going to hook up the hand to this other socket that we've got here. The only difference is that it's got a USB cable connected to it. But we have a specific mode on our hand that allows you to do position, velocity, torque control over all 6 of the motors, stream all the touch sensors over Bluetooth or over a USB connection, as well as all the encoders, which tells us what the positions of all the fingers are. And we can stream it to my phone, we can stream it over the internet or whatever. And then people are able to control the hand that way. And so if you want to try actually controlling the hand from where you are in New England, we can actually make that happen. So if you put your hand to the camera.
Okay, I haven't been trained for this, so.
Yeah, so move it. Yep, there you go. Yeah, so you are controlling this hand. all the way across the entire United States.
Congratulations, you're a telerobotics operator.
That's crazy. Yeah.
And so this
And
is
the rock-
the
the
level
rock
of,
on.
oh, sorry, oh, yeah, you want to go for it. We'll do one more. Yeah, there we go. Nice, rock on. And so this is the technology that we're developing that's going to be coming out in the future, right? So this naturalistic control of where you can control individual fingers, and then when you actually touch these digits, right? So if you touch the end of the finger, then we can stimulate your nerves and make it, instead of just a vibration, which is what it currently feels like through like your it feels like a cell phone vibration, right? By stimulating your nerves, we can actually make it feel like it's coming from your hand that's no longer there, like from the fingertip.
Mm-hmm.
And when we get to that level, then this no longer just becomes, a tool that you use in your daily life, but rather an extension of your body.
Mm-hmm.
And that is the future that we want to head towards, right? So Sergeant Anderson, actually feels like he has his hand back, right? Mm-hmm. And we're really excited about the prospects of where we're bringing this stuff in the future.
Mm-hmm. Well, I'll say there's a decent chance that there are some advanced technologies groups of large orthopedics medtech companies listening in on this talk. I could see some collaborations, and I'm sure you're already in talks with these folks. But yeah, it sounds like extension of a medtech, large medtech organization at that point.
And we're about to actually start an equity crowdfunding campaign too. So for anyone who's interested in investing in the company too, we've got a lot of exciting stuff that's going to be happening in the near future.
Perfect. Well, any other parting words or anything else you want to share with the audience before we wrap up here? It's really been an honor to talk to both of you and hear how you're using our technology.
I mean, I guess for me, the most important thing in this entire process has just been coming at this from just a viewpoint of gratitude. I'm incredibly grateful for the opportunity that we've had to do something that we've always wanted to do, like for me, my entire life, but also for the opportunity that we've had to work with such incredible individuals like Sergeant Anderson and Dan St. Pierre and Kate Kettlehone. And to make a difference in their quality of life, right? That's why we do what we do at Psionic, and that's what we hope to be doing for the next 50 plus years that we'll be doing all of this stuff. So thank you for having us here, Gaurav. And James, I don't know if you had any additional parting words. But...
Oh yeah, just a few. Go on a huge spiel now. No, I'm also extremely grateful to be able to do this work, to work at a company that's both this cutting edge and also this personalized and patient focused, which is something I really love. I was going to mention earlier when we talked about comparison to hook prostheses. Mm-hmm. Surprisingly, to some extent, they're extremely popular still today, even when we have a lot of these advanced prosthetics around. And it's because the advanced prosthetics don't necessarily answer what patients actually want. They want something extremely reliable that they can do their task with day in and day out, and it won't break. It's affordable and it's usable and it's repairable. And so these hooks have stuck around for a long time, even if they seem low tech. We want something that is both high tech and fulfills the need that current advanced hands aren't fulfilling. And I love that that's something that we can do with the ability hand, and that we aim it so much towards patient needs. I mean, if a patient tells us, oh, it can't quite do this, or is having trouble doing this, or there was an extreme case and this broke, we'll take it back and we'll improve it and fix it and make it better for next time so that won't happen anymore. And just having that opportunity to work in this field in general and have that mindset is fantastic for me. Yeah. We couldn't do it without Formlabs 3D printing.
Yeah. Well, I'll say that there are you have many fans here at Formlabs and likely in our extended network. Disconnecting the dots. We have a mission statement of making digital fabrication accessible, so anyone can make anything. And these are some of the most impactful cases that we can imagine. So. Your drive and focus on accessibility and affordability is very much in line with our approach, and it's great to see what happens when these mashups come together, if you will. So thank you both for the work that you're doing and for taking the time with me today, and really best of luck from bottom of all of our hearts here for the future, and stay in touch.
Thank you.
Thanks so much.
All right, take care.
Thanks.